Hey folks, Mr. Long here. Going to do a screencast on
solving
systems of equation using row operations.
So here's what we're
going to work through today.
What you see is
an example in front of you, and you see system of three equations and three unknowns. This means we have three planes, and we want to find out if they intersect and how they intersect. They might intersect in a single line, they might intersect at a single point, they might not intersect at all. First thing we should always do when we're looking at three planes is to draw their normals. So here we go. Or not to draw them, but to get the equations of their normals. So the first normal is 1, 1, and 1 because of the x, y, and z. It's the coefficients in front. The second normal is 2, 0, because that's 2y, 0, 2, and 5. And the third normal to the third plane is 2, 5, comma, negative 1. Then what I have to do is examine those normals and see if any of them are parallel. So if they're parallel, they would be scalar multiples of each other. So, for example, this one here being 1, 1, and 1, another one would have to be 2, 2, and 2, or 5, 5, and 5, negative 10, 10, and 10, something like that. Alternatively, if I was looking for something that was parallel to the second normal, by the way, if the normals are parallel, then the planes are parallel, right? That's the whole idea there. 0, 2, and 5. Something else that would be parallel to that would have to be 0, 2, and 5, or 0, 4, and 10. 0, 20, 50, so it'd be 10 times as big, right? So it doesn't look like any of these normals are parallel. So the next thing you probably would do is really you would do N1 cross N2, get that answer, and do the dot product with N3. And if that was to equal 0, that would mean they intersect. You'd go through it, and then they would either intersect in a single line, or in three lines, like the triangle. So that's if it was 0. If it was not 0, that would mean they intersect at a single point. Okay, so this is a line or three lines. This one is inconsistent, this one is consistent. Okay, so in terms of analyzing normals, first thing you do, are any of them parallel? So are any of the planes parallel? Are they parallel in the same plane or parallel and distinct? We don't know. Or what we do know in this case, because none of them are parallel. So now it's time to do our row operations to solve for x, y, and z. So the first thing we do is we set up what is called a coefficient matrix. And so I take the coefficients of all of those. So the coefficients of the first equation is 1, 1, 1, and then the constant is 6. Next, the next one I do, coefficients are 0 for x because there aren't any x, 2, 5, negative 4, and then the third equation, the coefficients are 2, 5, negative 1, and the constant is 27. Okay, so now I put those in directly as they are, but what I really should have, I guess I should have spoke about with you, is the fact that you always want a 1 as that first, if possible, as the value in the first row in the coefficient of x, because that allows you to do row operations a little bit easier. So our goal is to get zeros in this triangle. Okay, you want to get zeros in that triangle. And that's, if you get zeros in that triangle, and you had ones in the diagonal, here, here, and here, that's called row echelon form. You don't really need to get ones in that diagonal, but you do need to get this triangle to be 0. The whole idea is that we can get zeros in the first two entries here, and then this will give us one of the solutions, the z solution. So let's start working through this. We've got a 0 here, so that's already done. Next thing I need to do is get a 0 there. So I always want to get zeros in those second and third rows, first column, every time. That's how I start out. So how am I going to get a 0 in the third row? Well, I can combine it with the first row, which is the idea. And I would need to, in order for
I would need to make the
first row have 2 for me to add or subtract it from 2 to get 0. So what I'm going to do is I'm going to double
the first
row. So that 1 is going to become 2, that 2 is going to become 2, double of 1 is 2, double of 6 is 12. So what I'm doing now is
I go to R3.
I go to R3. Okay, I go to R3, and R3 is going to be R3 minus
2
of R1.
Okay, so
I'm going to the new R3 is the old R3 minus double of R1. And what that does is that's going to get us 0. So if I look at this, so I'm going to take row 3 right here and subtract off double of R1. So first one I've got 2 minus 2. That's 0. Then I've got 5 take away double, which is 2. So 5 minus 2 is 3. Then I've got negative 1 take away 2. Negative 1 take away 2 is negative 3. Next I've got 27 take away 12. 27 take away 12 is 15. Okay, so what I should do now is enter in the rest of the rows as I see them. So the first row is 1, 1, 1, 6. I don't put the new one in of 2, 2, 2, 12 because that's more complex. Then I put in the second row, which is 0, 2, 5, negative 4.
At
every step, and I should have done this the first step, I should have looked for common factors. Okay, so right now, in the third row, I can divide it by, if you look at that, I can divide by 3. Okay, so I can divide by 3. So if I'm going to divide the third row by 3, that's going to become 0 divided by 3 is still 0. 3 divided by 3 is 1. Negative 3 divided by 3 is negative 1. 15 divided by 3 is 5. Okay, so I just divided out by a common factor of 3.
Okay,
so now I look at this and I go, okay, how do I get rid of,
I need
to get a 0 now in this one, okay, and that will make my whole triangle. So what do I need to do to that? Well, I would have to take the third row and double it, okay, and then I could add it to the, add or subtract it from the 2 above. So let's try that. So I need to first of all double the third row. So that 1 is going to become 2. That negative 1 is going to be negative 2. That 5 is going to be 10. Okay, so now let's, our new row 3 is going to be, R3 is going to be double
of
R3 minus R2. Okay, so I'm going to double R3 and take away R2.
So double of
R3, which I've done right there,
in black.
I'm going to double R3, I'm going to take away R2.
Okay,
I never want to reintroduce. Once I've got zeros here and here, I never reintroduce the first row because I'd be reintroducing a 1 to keep these 2 zeros here. So I cannot reintroduce row 1 anymore as soon as I get 2 zeros there.
Okay,
so
let's see here.
So let's do, this is 0 minus 0, that's gone, and I'm doing this 2 right here, subtract 2, that gives me 0. I've got negative 2 subtract 5, which is negative 7. Then I've got 10 subtract negative 4. 10 subtract negative 4 is 10 plus 4, which is 14. And once again, I can see right away that I've got a common factor here of negative 7, because I always take out a leading negative. So I'm going to divide that by negative 7. So then that's going to be negative 7 divided by 7. Negative 7 is 1. 14 divided by negative 7 is negative 2.
So
now I've got 0, 0, 1, and negative 2. Remember that this right here represents an equal sign. Okay, that's an equal sign. So that means that 1 z equals negative 2. So now I've got
one of the equations,
and I can do, I've got one of the answers, now I can do back substitution. By the way, I would call this 4. Okay, so my first 3 equations are actually rows, row 1, row 2, row 3. So now what I want to do is take 4 and I should put it into row, in this case I can put it into row 2. Okay, 4 is going to go into row 2. There's my row 2 right there. Okay, 2y plus 5z equals negative 4. So let's do this. I've got some room right here. So I can put 4 in row 2. And again, what is row 2? Row 2 is 2y plus 5z equals negative 4. 2y plus 5z equals negative 4. I can isolate for y and say that 2y equals negative 4 minus 5z. What's z worth? Well, that's where we're going to replace it. Equation 4 is 1z equals negative 2. So that equals negative 4 minus 5 times by negative 2. That's what equation 4 is. Negative 4 plus 10, right? Negative 4 minus 5 times negative 2, so that's negative 4 plus 10 is 6. 2y is worth 6. Therefore, y equals 3. And that becomes equation 5. Okay, so equation 4 is z equals negative 2. Equation 5 is y equals 3. Now what do I do? Again, back substitution. Again, I move up another row. Okay, maybe this is pretty messy stuff. Let's go back up to the very first one. So there's the first equation, which is the first row. X plus y plus z equals 6. So now I can back substitute there. So I'm going to put 4 and 5 in row 1. What does row 1 say? Row 1 says x plus y plus z equals 6. X plus y plus z equals 6. Or x equals 6 minus y minus z. Z's negative 2, y is 3. So x equals 6 minus 3 minus negative 2. Okay, x equals 6 minus 3 is 3, plus 2 is 5. Okay, so now we have a solution, and it is in fact a single point. So our solution is, I'm just going to write it here, x equals 5, y equals 3, and z equals negative 2. So that would mean that plane, those 3 planes intersect at one point, a single point, and that's the location right there of the point of intersection. That would also mean that N1 cross N2, had we have done it, dot N3 would not have been 0. Okay, they would not have been coterminal. Coplanar. Okay, so there's our point of intersection right there, 5, 3, and negative 2. Again, how did we go about that? We started by putting all the initial information into a coefficient matrix, and then what we started to do is get those zeros in the diagonal. As soon as I get zeros in the diagonal, I solve for a single value. Okay, so I was able to do that. I had negative 7z equals 14. Which gives me z equals negative 2. Once I have one of the values, so if you noticed I had that diagonal, I had z, then I worked back up to this equation, that gave me y, then I worked back up to row 1 and back substitute again, and that gave me x. Okay, so that's your general process.
All right, folks.
So there you go. So get your zeros in that triangle, and then solve for z, and then back substitute. back up to row 2, then finally to row 1 to get x. Okay? So hopefully that helps.
Make sure you go
rewind these videos, try and do it yourself. Okay, so I'll actually just, you might want to write down the answers. There's your equations there. You also happen to have this handout, and you can work through it yourself as well.
Good luck.
Okay, good luck.